Solving absolute value equations and inequalities that involve absolute value. Alright? So before we get to jumping into all this stuff, we need to talk about this guy. Absolute value. Absolute value is a distance. And in particular, it is the distance from 0. Alright, the distance from 0 is the absolute value. Alright, so quick little example, just to give you a visual. When you look at this is basically saying how far is negative 5 from 0. So if we put this on a number line and we say negative 5 is here, negative 4, negative 3, negative 2, negative 1. And you count those units. How far is negative 5 from 0? 1, 2, 3, 4, 5. Now, how far is 5 from 0? Wow. 5 is also 5 units away from 0? Yeah. So, both of these equal 5 because it's saying what is the distance, how far away from 0 are those measures. Alright, now let's look in this little box right below it to get a little bit more theoretical. Now it says the absolute value of u equals a is equivalent to u equal a or u equal negative a. And that's exactly what we did up top. Our u in our case, our a, which u is equal to, was negative 5. Alright? So, but whenever we get into talking about these, I'm going to do some illegal things in the math world. But I'm only doing it because I want you to see a consistency through and through. So, what I'm going to say is, so that you can write this thing consistent through and through. Alright. First of all, you have absolute value of u equal a. Let's say we write that out like this. The illegal thing that I'm doing is the equal sign abuse. Because if you look at that equal sign, it could be easily assumed that I'm saying, well, negative a equals positive a, which is not the case. Alright, I just want you to get this little movement in your mind of negative. Whenever you see absolute value equal a and a is positive, because distance is always positive. Therefore, a lot of people say absolute value is always positive, which is true only because of that keyword that absolute value have in it, and that keyword is distance. Alright, let's move on. Now, when solving absolute value equations, you want to first ask yourself, is the absolute value by itself on one side of the equal sign? Yes. Now, if it is, next thing you want to do is, I recommend doing a sign check. And what I mean by sign check is this whole thing, because it's in absolute value bars, we know that this whole thing is positive because that's the distance. And then we have equal to a number that is positive. That tells us immediately, yes, we can do this problem. If we have agreeing signs there, or signs that are in respect to the symbol that's separating the absolute value and everything else, then make sure it makes sense and proceed with what we wrote before. All right, we have negative 10 equal x minus 3 equals 10. I'm telling you to save you a world of time to get this quick little legal abuse move in on that equal sign. All right. Now that I have just done that equal sign all in, we have our two solutions. X equal -7 or X equals 13. All right. Moving on to part B. Part B, we have, is the absolute value on one side of the equal sign by itself? Absolutely not. So we go ahead and we'll add that on over. And that gives us 2x, absolute value of 2x plus 1 now equals 10. Absolute value on the side by itself, yes it is. I'm doing a quick sign check. I have a positive equal positive. Lets me know, go ahead and do your problem, man. Alright, I'm going ahead and do it. I got -10 to the left. I go to 2x plus 1. And then I have my 10 to the right. Go left, go right, then solve. Left, go right, then solve. Alright. And just like that, we have our solutions again. So we have x equals -11/2 or 1/2. Okay, let's keep it rolling. I just toss that back real quick just in case you was writing. I forget sometimes that, people have to catch up when they're writing, and I just be going. Forgive me. Forgive me. All right, let's go. All right. So we have still solving. You can undo by multiplying by the reciprocal. So I'm going to multiply each side by the reciprocal of 6/5. And that leaves us with absolute value of x equal 5/6. And these are just cakewalk problems, man. I know what you're saying. You're saying, Trummer, challenge me. Put me to the test. Alright, I'm about to challenge you. Alright, we got absolute value of u minus 1 equal -1/6. Alright, some of y'all went ahead and started working. And I'm about to really rock your world right now. You can't do it. Because if you would have did your sign test, you see you got this thing right here. It's all positive. And then a positive equal negative, not happening. So with that being said, absolute value of an expression, whatever that expression is, if we have the absolute value of an expression equal to a negative, there exists no solution. No solution. Boop. Alright. Let's keep it rolling. Wait a minute, Drum. I know good and well you ain't just tossing a quadratic on me. You said challenge you. So here you go. I know you wanted the juice. Now you got it. Now, this is my thing with tossing in quadratics and all this whatnot. My thing is this. If this thing is not linear, you need to write it out twice. Otherwise, you're going to have a world of hurt. Okay? So just go ahead, write it out twice. So we went to the left on the first one, and then on the second one, we went to the right. Alright? And getting ready to solve this, we have x squared plus 5x minus 4. Is that minus 4? No. x squared plus 5x minus 2 equals 0. And that's what happened on the left side. And I'm just going to toss this into the quadratic formula. Write out my discriminant. I told y'all was going to wham that discriminant. That's in quadratic formula. That's why I wanted you to get it locked into your brain. Minus 4 times 1 times negative 2. Right, we got 25 plus 8 equals 33. Tossing that quadratic formula in there, x equals opposite of b. We have negative 5 plus or minus square root of 33 all over 2a. That's for the left hand side. Now when we toss this information into the right hand side, we have x squared plus 5x minus 4 equals 0. Again, go ahead, get your discriminant up in there. And that gives us 5 squared minus 4 times 1 times negative 4. It's 25 plus 16. 41. X equal negative 5 plus or minus square root of 41 all over 2. Hey, there you go. Keep it rolling, because we got things to do. Anytime you have absolute value on absolute value, don't be afraid. You just pick whichever one you choose to drop the absolute value bar from, and just write out your equations twice. I'm going to drop the absolute value bar from the equation to the right hand side. So I'm going to put to the left on this one. And I'm going to write this other one out again. And I'm going to put to the right on this one. And when I say to the left and to the right, I'm talking about to the left of 0, to the right of 0. Anything is to the left of 0 is denoted by negative. Anything to the right of 0 is denoted by positive. Distribute to the negative. And you'll go through and solve these things. 12x squared. 12x squared plus 9x equals 0. We pull a 3x out of both of those, so you're left with 4x plus 3 equals 0. And so x equals 0. X equal negative 3/4. Alright? And you'll do the same thing for this guy over here. Alright? Let's keep it rolling. Now, solving inequalities that involves absolute value. This is why I said, hey, you want to make sure you keep this thing consistent, because we're going to use these inequalities now to do what we were just talking about before and going all the way through. You see, your expression, your algebraic expression, doesn't change. It's stuck between inequality symbols, just like before. It was stuck between the equal signs. It's worth pointing out, inequalities by absolute value less than 0 is never true. Just think about it. Absolute value, we know that is always positive. If it's less than 0, can a positive be less than 0? Never. Right? Keep rolling. Alright, real quick, easy example. You have absolute value. Alright, right to the left of 0, write your value. Write the symbol that's present. Write your algebraic expression. Write the symbol that's present again. Now write to the right of 0. This problem is already done because x is by itself. That fast. Same thing again. We have to the left of 0. Write the symbol that's present. Write your algebraic expression. Write the symbol that's present. Now to the right of 0. And solve it. Alright, solving it, we have -4 on the left there. 3x. And that's a 6. Dividing everything by 3. And we have -4/3 less than or equal to x, less than or equal to 2. And I want you to graph it. We just went through this lesson prior to coming here. -4/3, 2, and boom, we have x is to the left of 2, and -4/3 is to the left of x. We'll put brackets because we have the or equal sign. Alright, and then right here, another very straightforward problem. Right to the left, the inequality symbol, the algebraic expression. Just tossing all kinds of x's and whatnot inside of there. Your algebraic expression, the inequality symbol, and to the right of 0. And then solve that guy. -7 is less than -2x. It's less than 1. Because what we did was we deducted 3 from everybody. And then we divided everybody by -2. But we did it across an inequality symbol. So that symbol flips all the way through. Problem said to graph the solution set. We have -1/2 to 7/2. X is to the right of -1/2. So x is to the right of -1/2. To the left of -7/2. Okay, let's keep going. And then pay, like you can look at that, but again, I really want you to focus on making sure you keeping that thing consistent all the way through. I tell you, when you write combined inequalities, the symbols will never flip. Alright, we have, let's go to the left of 0. Alright, the main symbol that we're focusing on here is greater than. Put your algebraic expression, keep your symbol the same direction, and then go to the right of 0. Alright. Another noteworthy statement. Look at this. Alright, it says of the absolute value of, that should be make that a little bit cleaner. Alright, absolute value of u is greater than a. And if a is negative, It said assume A is negative. So you have something that's positive greater than something that is negative. That's always true. Positive is always greater than negative. So your solution would be all real numbers. Alright? Don't say I did not tell you. That's how my niece would say it. Don't say I ain't tell you. Alright. So now we have, let's go to the left. Keep our inequality symbol. Put in your algebraic expression. Now go to the right. Done. Alright, we're going to go to the left. Keep my inequality symbol. Now go to the right. And solving. We have negative 5 greater than 3x, which is greater than 9. Dividing everybody by 3. We have negative 5 thirds greater than x greater than 3. Negative 5 thirds, 3. Says x is to the right of 3. Watch out now. Whoa. You ain't seen this one yet. So we shading to the right of 3. And it says negative 5 thirds is to the right of x. Whoa. So x is out here and x is out here. And we are going to infinity. Wow. So the way you would write that, in interval notation, you went to the left forever, from negative 5 thirds, union, to the right forever. Alright. Alright, that right there, my friends, was solving absolute value equations and inequalities. Alright. Peace out.